Okay, hello again folks, it's me, Mr. Weston. How are you all right? So here we are, Factorising 2. This is going to be your work for Thursday. It will be Thursday, the 2nd of April. I'm struggling here to remember the dates. Anyway, and of course that will be your last work until after the Easter holidays, because you've got 2 weeks off then, which is a bit weird, I know, but hey-ho. But, well, at least it's a chance for you all to catch up on all the other videos that you perhaps not seen yet, and also catch up with all the other work on your turn sheets. Anyway, so we'll look at Factorising 2 for now. The idea is here, we've got non-like terms, that's the idea. So we've got sums or differences, you know, in fact, I think, no, there's a minus there. But things that can't simplify or group together. I think that's the main thing. So if you look at this first one, 5ab had 3a. ab's and a's are not the same, as we've said in the past, so they don't add together, we can't simplify. But the idea or the concept of factorising is you look at both parts, or however many parts there are, this one's got 3 later on, and you find out what is common, okay? The idea is find the highest common factor and then you can take that out, okay? It's the opposite to expanding. But let's have a look at this first one anyway. So we'll look for the highest common factor of these two pieces. We've got 5ab and 3a. Now the way I've always done it is you basically break it all down. So you've got number, or the number part of it, and then look at all the different letters. So like A's, B's, C's, D's, E's, F's, and so on, okay? So in this case, I would go 5 and 3. Highest common factor, well, 1. Nothing goes into them both, so 1, there isn't basically in my head, no highest common factor. Now we'll look at A's, A in the first bit, A in the second. Oh, cool, well, they share an A, bingo. Then we'll look at B's, B in the first one, not in the second one. So only A is common to both parts. So if we take the A out, basically now what I'm going to do is put them in brackets and say to myself, what do I times the A by to get to 5AB? Basically, all the rest of it that wasn't an A. So 5AB, we've took the A out, we're left with the 5B. And then we've got the 3a here. So what do I times a by to get to plus 3a? Well, we've took the a out, I'm just left with a 3, or the plus 3. And that's factorisation. And the idea is if you wanted to, you could then check and multiply out, just like we've been doing, expand the brackets, and you get back to what you started with. Okay, let's look at this next one then. 8, CD, add C. So just the same, number, 8, 1. Invisible 1, admittedly. But highest common factor, 1, don't worry about it. 1's basically the number, just it's there anyway, so don't worry about it. C and C, okay. There's 2 C's. CC Peniston, you won't remember that, it's 1980s. Anyway, C and C, so that's common to both. D, no. D in the first, but not in the second. I'm losing track of what I'm talking about here. So only C is common to both bits. So we take the C out. What do I times C by to get 8CD, or all the rest? It's just going to be an 8D. And this one does catch people out. What do we times C by to get to C? Or people go, nothing, you've already got the C. Well, yeah, true. But you think about it, what's the one number you can multiply by that won't change the number you've got? And that is number 1. So C times 1 will give me C. So C times plus 1 will give me plus C. And again, what I've now got is the factorised form. If you wanted to check, you could just times out the brackets again and expand it. Okay, this one, a bit trickier. So let's have a look. Number first, 4 and 3. No, nothing in common. A squared and A. Oh, okay, squared and A. Well, they've both got an A in them, haven't they? So if we take the A out, be careful here. What do I times the A by to get 4A squared? Well, obviously the 4, but just timesing those two, I get 4A, not 4A squared. So I need another A there, i.e. A times A is A squared. A times what is plus 3A? Well, that's easy, plus 3, and that's your lot. Okay? This one's got 3 parts. We don't normally deal with as many of these 3-part ones, but the principle is exactly the same. We've got 3 bits, so we look along them all, okay, individually. So we look at the number for a start, 5, 3 and 6. Anything common? No, nothing common at all, so 1 if you want to say it, but basically nothing we can take out. Now we'll look at the rest of it, A cubed, A squared and A. Okay, they've all got an A in them, that one's only got 1, but okay, we'll take the A out then. So take the A out. And then what we'll look at now is, what do I times A by to get to 5A cubed? Well, we can obviously see the 5, But how many a's? You know, and this is the idea. You can imagine people going wrong here. A times what gives me a cubed? Well, a times a is a squared. A times a squared will make a cubed. So if I put a squared there, sorted. A times what is 3a squared? Well, we can see the 3. We'll need another a though, because a times a is a squared. And last but not least, a times what is minus 6a? Minus 6. So what we've done is we've pulled out that a because it was the common factor from the 3 pieces. Okay, this next one, a bit harder. 6ab and 8b. So again, if we're systematic about it, we can start with a number. What's common? It's easy to go, nothing, 6 and 8 are different numbers. But 6 and 8 are both even. They're both in the 2 times table. So basically that means that both these pieces here share the number 2. They also share a b, not an a, because there's only an a in the first one, but they certainly share a b. So I can take the b out. And then I'm asking myself, what do I times 2b by to get to 6ab? Do it in stages, just the same as 2 times what is 6? Don't all shout at once, that's 3 by the way. Got the b, and we need the a, and so it'll be 3a. And then for the next one, what do we times 2b by to get to 8b? Well, we need a 4 to times the 2 by, and then of course the b's already there. Done. Okay, next one, 3 to go. So, oh, he's fallen over, my little guy, with his balloon. 5cd minus 15d. So again, let's start with a number. What is common? 5 and 15, both in the times table. You all shouted 5, so we'll take 5 out. C, no C, so C is not common. D, check, D is common. Take that out then. So now 5D times what gives me 5CD. Well, I've got the 5, got the D, you just need the C. And then 5 times what is 15? Minus 3. I've got the D, so I don't need to worry about it, and that's the answer. Okay, simple as that, isn't it? You're all thinking, okay, I won't say what you're all thinking. Okay, the next one, 7a squared add 14a. Now we're getting a bit more like the stuff you're going to have to deal with. 7a squared and 14a. So we'll look at the number first. 7 and 14, both in the 7 times table. Take the 7 out. A squared and a. Basically, a goes into both of them. They're both in the a times table, if you want to say it like that. It's a bit weird. So 7a is the common factor. What do we times it by to get 7a squared? Well, we've got the 7. We've got one of the a's. We need another, i.e. a times a is a squared. Check. And then 7a times what is 14a? Well, 7 times 2 is 14. And of course, we've got the a already. And there we go. And then this last one that looks horrendous, but it's not as bad as you think. We're systematic about it. Start with the numbers 4, 12 and 10. Well, they're all even, so they're all in the 2 times table. Now let's just look at letters. So we'll start at the beginning. A. Brilliant. A is common to all 3. We'll take it out. B, no B, B, which is good. So you've got 2 B's, but you'd need the B in there as well to take the B out. It's not there. I'm sorry, we can't carry on. C, no C, no C. So C is not common either. We don't even need to try the D and the E because basically we know it's not in this first one here. So we know the only letter that's common to all 3 is the A. So take it out. What do we times 2a by to get 4abc? Well, 2 times 2 is 4, so there we go. What letter? We've got the a already. We need the bc, and that's that sorted. Now on to the next one, 12aed, or whoever made up all this. So 2 times what gives me 12? That'll be 6. We've got the a, we need the ed. And then the last one, take away this time, all right? Doesn't really make a difference. 2 times what is 10? Well, that'll be 5. We've got the A, we need the B, D. And I can close my brackets, and job is a good one. Okay, so listen, I'll set you in a hectic maths task, and then over the course of these holidays, it's time for you to catch up, and then there will be some more tasks, including questions that we'll be checking over all the stuff we've done so far in the last 2 weeks when you come back. That sounds weird to say come back, but when we start doing work again, and your email will be there on that first day, I think, for you. I think it's on the Monday anyway. But look after yourself, stay safe, be happy, try and get some fresh air if you can do. And need anything mathematical, just give me a shout, okay? Take care. Bye-bye.